We're now going to show you how to graph a parabola. And to graph a parabola, you first need to find the vertex, which for the simple problems we're going to start with is at 0, 0. You need to find the focus, which is at P0 or 0P with plus or minus. And you need to find the directrix, which is always a line at either an x or a y equals a value. No, this would be x equals a value. X equals minus plus p, so it's the opposite sign of this one. Or y equals minus plus p, and it's the opposite sign of this one. So these are opposite signs. Then it's helpful to know the length of the latus rectum. The latus rectum just gives us a much better shape of our graph, and its length is 4p. So, this next page that we're going to show you has a chart that outlines all the graphs. So here's our y squared equals 4px. Notice that the y is squared, then it's going in the left or right direction, positive to positive infinity, negative to negative infinity. If the x is squared, then it's going up or down, just like we would expect. And it goes up if it's positive, and it goes down if it's negative. So notice the vertex is the same. It tells us which direction it opens. It gives us the axis of symmetry, which will always be one of the axes until we start translating. The focus, notice the signs on the focus, and the directrix, opposite sign of P, and for the y squared it's an x equals, and for the x squared it's a y equals. So let's actually demonstrate this. X squared equals 12y. The first thing we should do is grab the number and compare this to set 12 equal to 4p, so that when we divide by 4, we get 3 equals p. So now we know what p is. Well, now we just start getting our pieces. The vertex is easy. This is just at 0, 0. We know it's going up or down because it's an x squared. And in particular, since that 12 is positive, it's going up. And we also know that the focus is at 0p, so it's at 0, 3. So here's our focus. Notice I'm marking this in red. We're not going to pass through this, but we're going to draw it. And our directrix, oops, let me write this in black. Directrix is at y equals a negative 3. So it's down here, negative 3. Well, now that we know that, we can actually use the latus rectum. So this gives us our basic idea. But when we use the latus rectum is at 4p, or notice that's going to be this number. It's 12 across. And so what we do is we go to the focus and we split that 12 in half. So we're going to go 6. We're going to go 1, 2, 3, 4, 5, 6. And we're going to put a point right there. And 1, 2, 3, 4, 5, 6. And we're going to put a point right there. And now all we need to do is draw our parabola so it passes through that point. Make it a little bit more cup-shaped, but I'm not going to be too picky about this. And we have successfully graphed x squared equals 12y. So notice how important it is to get this p. Let's show one more example. Y squared equals minus 6x. So in this case, we take the minus 6 and set it equal to 4p. So we divide by 4, and we get that p is minus 3/2. It's a y squared, which means it's going to be going left to right. In this case, it's going to be going left. Our vertex is still at 0, 0. Our focus is at minus 3/2, 0. So our focus is 1.5 over. And our directrix is at x equals 3/2. So it's this line right here. Our latus rectum is 6. We take the absolute value of it. We cut that in half, and that says we go up 1, 2, 3, and we go down 1, 2, 3, because that's half of the length. And our parabola looks like it's going to do something like this. And we have now graphed our parabola.